Welcome friends, we are starting our third unit, Theodolite surveying. Here there are two images in this slide. One is the actual theodolite photo, another one is the cross-section image, drawn image of the same theodolite, and here you can able to see the parts of those theodolite. We are going to see in detail about this also. But what is the main objective and use of this theodolite, and how it going to rule compared to any other instrument, and what are the changes happen to this theodolite in the later time? That is the major thing we are going to concentrate on, and how it makes our measurement very simple and very detailed. That is the main objective of the theodolite surveying. Right? Introduction about it. Suppose we need to determine the elevation of this building, or what is the distance between these 2 points. How I can obtain? Yes sir, we can do by leveling. Yes, it is possible. Maximum is the staff height is 5 meter, but without the staff can we do? That is the thing. In the theodolite we can measure both the horizontal and the vertical angle, such that from our straight line of sight we are able to measure the vertical angle also, and if it is perpendicular to it, so you are obtaining this angle. So based on the mathematical logic and trigonometrical principle, we can determine the horizontal distance and the vertical distance also, right? Similarly, if I am able to measure the angle between this end to that end, that is a horizontal angle, I am able to obtain the distance of the object without touching them also, right? That is the major advantage of the theodolite, that it can give both the horizontal and vertical angle, and it is more precise than magnetic compass. How it is? The magnetic compass is able to give the north, but the accuracy is the magnetic compass. Already we have seen the least count of the compasses are 30 minutes, right? But in the vernier theodolite the accuracy may up to 10 seconds or 20 seconds. Predominantly all the equipment in our laboratory is 20 seconds. In both the scale, if you make an average, you can get up to 10 seconds. So in general, the least count of the theodolite is 20 seconds. Please remember, it is 20 seconds. Compared to the compass, 30 minutes, it's difference from 20 seconds. So the accuracy get increased. There are variety of theodolite: vernier theodolite, optic theodolite, electronic theodolite. The vernier theodolite, we have to make the reading. In electronic theodolite, it will display the reading, and the advanced version of this electronic theodolite is the total station, right? So these are the variety of theodolite. This is the vernier theodolite. In our laboratory also we are having the same equipment. The color is different, black color, but I have shown here in the orange color, red color. The color is not the important here. And one more, this is the electronic theodolite. Here the display will automatically shown. Here we have to read the reading from this position. Opposite end also the same provision will be there. This is the place where you have to read the reading with the help of this lenses. And similarly for the vertical angle, you are having the provisions of measuring the reading in this way. For that the lenses are provided. And this is another variety of theodolite. And next is the advanced version of these things is the total station, right? Same methodology, but here the signals and recordings is possible. In this, recording is not possible, but the reading can be displayed as in the digital format. Here all the thing will be in manual, but you are understanding ability, if you are good in this, you can handle any other instrument, right? Next comes to the parts. Already you have seen this same image in the first slide itself. Transit vernier theodolite. These are the major parts you have to remember. Many times for a theoretical portion in the exam point of view, they may ask, explain with neat cross-sectional detail of the theodolite with parts and explain each parts. They may ask even for 10 or 15 marks also. So please concentrate on the diagram. In the next slide also we are going to show the cross-sectional diagram, which is available in the books also. That also I have shown, right? So you try to remember in different set of parts. From the bottom we will try to see. This portion is the tripod bottom. This is the continuation of the tripod. This is the top of the tripod, where we are going to place the theodolite over it, and we are going to hold by the screw, right? And this is the bottom portion of that. This total setup is called the leveling head, and it is connected by the leveling screw or the foot screws. The same screw we come across in the dumpy level also. 3 foot screws. In the cross section we are able to see only 2. One more will be in the perpendicular end, right? So these foot screw, and there is a circular type projection. This is called the ball and socket arrangement, which will be hold on here, and this is the connecting portion of the theodolite and the tripod, right? And this is the provision called the hook, where you can hang the plumb bob such that we can check the verticality of our instrument, and where the ground point is we can check. This is the dotted line shown is the vertical axis from top to bottom, and this is the horizontal axis of the instrument we can make. The horizontal axis is also called a Strunian axis, vertical axis, right? And this is the telescope, which can be rotated 360 degree in both the way, in clockwise or anti-clockwise. You can rotate the telescope also, right? And which can be hung at a particular position also. So this is the horizontal axis, vertical axis, tripod portion, leveling head, and this leveling head we are going to see in detail, and remaining parts, each and every parts we are going to see in detail. Just I try to make a point about it. The foot screws is connected with the tri-back, which is the holding point of the major portion of the theodolite, tri-back arrangement, right? So by adjusting these foot screws, I have explained the leveling of dumpy level. Either first two foot screws either inward or outward, and the third one in the perpendicular thing, right? The same procedure has to be adopted here also, right? Here the level has to be checked with this, the plate level. This is the horizontal plate so horizontal plate level. This bubble has to make center. And one more thing additional to the dumpy level is in theodolite you are having the altitude bubble also, such that the vertical axis and the horizontal axis has to maintain in a perpendicular. This bubble also should be in center while doing our leveling. So you have to check in both the thing, right? That is the additional thing, since it is for our accuracy purpose. Next, this is the lower plate and this is the upper plate. The lower plate is also connected here, and the upper plate is also, the total setup is called the spindle. The spindle, it is called as outer spindle, inner spindle, and in the lower plate only the circles of measurement or graduations of the angle is marked, and the upper plate also has some setup. Through the continuation of the upper setup only there will be a frame. That frame we can see in detail about. It is a A-frame setup. In that A-frame setup only the telescope is attached, right, such that it can be rotated, and this is called the vertical circle, in which the graduation to measure the vertical angle, the provision is given, and the bubble tube is attached. To adjust the verticality, vertical clamp screw is available, and this is the telescope, this is the objective end, this is the eyepiece end, right? This is the overall parts of the theodolite we will see in detail.